Hello everyone. In this video, I'm going to explain and solve some of the numerical problems on Coulomb's law. Okay. So basically, this law explains the nature of force between any two charges. So basically, we have two kinds of charges. One is positive and the other one is negative. So if we bring two charges, it may be positive positive, positive negative, or negative negative. What is the nature of force and what is the magnitude of force acting on each other and what is the direction in which the force is acting? All those things can be found by using Coulomb's law. Okay, here I'm going to explain the Coulomb's law first, then I will solve numerical problems on it. So initially, the Coulomb's law is the magnitude of force between any 2 point charges. Here we are considering 2 point charges is directly proportional to which one? The magnitude of force is directly proportional to the product of the magnitude of two charges and inversely proportional to the square of the distance between them, and the force always acted along the line joining the two charges. Okay, so mathematically it can be represented as the magnitude of force is directly proportional to the product of the magnitude of charges. So F is directly proportional to Q1 into Q2 and inversely proportional to the square of the distance between them. If you consider one charge here and another charge here, so this is Q1, this is Q2. The distance between them, between the centers of two charges, is R. So square of it. Okay, so that means we will get F is directly proportional to Q1 Q2 divided by R square. If you remove this proportionality sign, you will get a constant that is 1 divided by 4 pi epsilon naught. Okay, so then here the force F is between Q1 and Q2, and that will be in Newton, and epsilon naught here is a constant and its value is 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. Okay, and it is called absolute permittivity of the free space. Then Q and Q2 are the two charges and distance between them is R, that will be in meter, and charges are represented by Q and their unit is C. Okay, so now according to this statement, the force always acts along the line joining two charges. What does it mean? If I consider any two charges here, let's for example, let's take this plus charge. So we already know the nature of force between two like charges is repulsive. It may be plus plus or minus minus. That means this exerts force on this in this particular direction and this exerts force on this in this particular direction. So they move away from each other if they are brought close to each other. There will be force of repulsion between the two like charges. Here also these two are like charges, they repel each other. When they are unlike, when a positive charge brought near to a negative charge, those two attract each other, but they are acting along a straight line. Here also straight line, here also straight line, here also straight line, joining the two charges, centers of two charges. Okay, so here I can't say the force is acting in this direction, I can't say force is acting in this direction, it is acting along the line. Okay, it is acting along the line joining two charges. So this is all about the Coulomb's law. Now let us solve numerical problems on this. Do remember this? F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 by R square. Here we can solve so many problems on finding F, that is force, and finding R square, and finding Q1 Q2 also. Okay, and here we consider these two charges are present in space. In space. If we consider if the two charges are present in any medium, we will get one more constant here, that is epsilon r. Okay, so here if we consider In space, epsilon r will not be there. Okay, do you remember this? That's it. Okay, dear students, we have the first question, that is the force between two charges separated by a distance of 1 meter is 1.8 Newton. The charges are in the ratio 1 is to 2, then the charges are. So here we have two charges Q1 and Q2. We don't know their magnitude. That is what we have to find. But they are separated by 1 meter. So R value is 1 meter. This one is 1 meter. It is in SI unit only. Then the force between them, it may be attractive or repulsive. They have not given that, but force between them is 1.8 Newton. Force is given, R is given. So what we need to find, Q1 and Q2, and they have given one hint also. What is that? Q1 and Q2 are in the ratio 1 is to 2. So from the data given, I have written here. So force is 1.8 Newton, R is 1 meter, Q1 by Q2 is 1 divided by 2. Okay, so from this I can get to know. So Q1 is equal to 1 by 2 times Q2, or Q2 is equal to 2 times Q1, isn't it? Q2 is equal to 2 times Q1. So now we need to find out Q1 and Q2. I will use Coulomb's law force here. Okay, so that is Coulomb's law of force is F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Let's substitute all the data here. So here F is how much? 1.8 Newton, and we should know its value. Okay, so its value is 1 divided by 4 pi epsilon naught, value is 9 into 10 to the power 9 SI units. Okay, and Q1 as it is, so Q2 is 2 times Q1. I will write that here. I will find Q1 first, then I will find out Q2. So R is 1 meter. Okay, so then now 1.8 is equal to 9 into 10 to the power 9 into Q1 into Q1 square, and 2 as it is. Okay, so now I can find Q1 square first, that is 1.8 divided by, this will come to denominator, 2 also will come to the denominator, that is 9 into 10 to the power 9 into 2. Okay, so if you bring 9 into 10 to the power 9 here to the denominator and 2 to the denominator, will get this Q1 square. So Q1 square is equal to 2 9s are 18, so this will be 0.9, and 9 1s are 9, so you will get 0.1 here. Okay, that means 0.1 divided by 10 to the power 9, so that is equal to 10 to the power minus 10. Okay, so Q1 we want, so that means square will come to the right hand side, so that means you will get 10 to the power minus 10. Okay, then Q1 is equal to how much? 10 to the power minus 5 Coulomb. Okay, this is Q1. And what is Q2? Q2 is equal to 2 times Q1, so I can write that here. Q2 is equal to 2 times Q1, so that is 2 into 10 to the power minus 5 Coulomb. So Q2 is equal to 2 into 10 to the power minus 5 Coulomb. That's it. So Q1 and Q2 are this 10 to the power minus 5 Coulomb and 2 into 10 to the power minus 5 Coulomb. Thank you. Okay, we have next question here, question number 2. That is 2-point charges QA is equal to 5 microcoulomb and QB is equal to minus 5 microcoulomb are located at A and B separately by 0.2 meter in vacuum. Okay, so what is the magnitude of force between the two charges is the first question. Okay, we can call it as first sub question in this. Then the second sub question is, if a negative test charge of magnitude 2 nanocoulomb is placed at O. What is that O? Actually, it is at the center. You have to consider this is O. Okay, at O. What is the force experienced by the test charge? Okay, now for I will solve the first question, then I will solve the second question. So first question, according to the data that I have, two charges are there. Q1 is 5 microcoulomb, or you can consider it as QA also, and this one is QB. Okay, QA is 5 microcoulomb and QB is minus 5 microcoulomb. Force between these two is directly proportional to product of the magnitude of charges and inversely proportional to square of distance between them. So from this I can get 1 by 4 pi epsilon naught value is 1 by 4 pi epsilon naught value is 9 into 10 to the power 9. Okay, its value. Then Q1 is magnitude of QA and QB. QA is 5 into 10 to the power minus 6. Micro is nothing but minus 6. Do remember this? Milli means 10 to the power minus 3. Okay, micro mu is 10 to the power minus 6. Nano 10 to the power minus 9. Pico 10 to the power minus 12. At least you should know this. And femto is there. Femto means 10 to the power minus 15. Okay, do remember these prefixes. So then into Q2 is magnitude of Q2, that is 5 micro means 10 to the power minus 6 coulomb, divided by R square. So R is 0.2 whole square. Okay, so then this is equal to 9 into 10 to the power 9 into 5 into 5 25 into 10 to the power minus 12 divided by 0.04, 0.2 square. And if you solve this, you will get how much is that? 5625 into 10 to the power 12 minus 9 minus 12 is minus 3. So this is the answer, or you can write like this: 5.3123625 Newton. So this is the force between two charges. Simple is that. So next we have the second question, that is, if a negative test charge of magnitude 2 nanocoulomb is placed at O, that is actually at the center, you can write here at the center, what is the force experienced by the test charge? So here we have two neighboring charges which can influence or which can exert force on this test charge, which is placed at the center or at O. Okay, so first I will find out the force due to this one and this one, then I will calculate the force due to this one and this one. Actually, the magnitude of forces on test charge due to these two charges will be same. Why? See, here also we have 5 microcoulomb, here also we have 5 microcoulomb. Okay, it doesn't matter what is the sign of this, but magnitude of force will be same. Okay, let me solve this. So force on this one due to this one, let me consider that is Fa. Force on this one due to this one, let's consider that is Fb. So then the distance between them will become, from here to here it is 0.2, means from here to here it is 0.1. So means we have to consider distance as 0.1. Here also 0.1, this distance. Let me find out Fa. Okay, so now Fa is equal to 1 over 4 pi epsilon naught Q1 Q2 by R square. So that is equal to 1 by 4 pi epsilon naught value is 9 into 10 to the power 9 into Q1 value is how much? That is 5 microcoulomb is 10 to the power minus 6 into 2 nanocoulomb charge is placed at the center, means 2 into 10 to the power minus 9. You should have the data properly, divided by R value is 0.1 whole square. So that means that will give 9 into 10 to the power 9 into 5 into 5 to the 10. I can directly write 10 to the power minus 6 minus 9. Okay, I can write directly minus 6 into 10 to the power minus 9 only, because I can cancel 10 to the power plus 9 with minus sign, divided by 0.1 whole square is 0.01. Okay, so that is equal to 9 into 10, 90 into 10 to the power minus 6. If this comes to the numerator, it will become 10 to the power plus 2. So force on test charge due to the charge placed at A is this much. How much is that? 90 into 10 to the power minus 4 Newton. So in the same manner, force on test charge due to the charge placed at B is given by F is equal to 1 over 4 pi epsilon naught Q1 Q2 by R square. So Q1 is 5 into 10 to the power minus 6 into test charge is 2 into 10 to the power minus 9 divided by zero point 0.1 whole square. That will also give you the same value. Okay, so that is FB. So total force acting on test charge is, so since the magnitudes are same, I can consider like this: F is equal to FA into 2 times. Okay, or you can add these two, so that will be 90 into 10 to the power minus 4 Newton into 2 times. That will give you 92 is a 180 into 10 to the power minus 4 Newton. Okay, 180 to 10 to the power minus 4 Newton. So this is the answer.